Hi, this is Ms. Heaney again. This is the last lesson in this part of the unit, absolute value equations. This is probably a new thing that you have not seen before. In this lesson, we're going to solve equations that have absolute value symbols. Those are those straight up and down lines that you see sometimes. What you probably know about absolute value is that thing that makes numbers positive. So like you can see here, absolute value of -3 is positive 3. Absolute value of 4 is just still 4. So it takes whatever number and makes it positive. That's great. But what happens if we have an equation that has absolute value in it? There's some extra things that we need to worry about. Oh, by the way, we are on page 99. I don't think I mentioned that, page 99. All right, so absolute value is that symbol that makes numbers positive, but that's actually not really what it is. The official definition for absolute value is the absolute value of x is the distance between x and 0 on a number line. And those straight up and down lines are the symbol for absolute value. So the reason why -3 has an absolute value of 3 is because it is 3 units away from 0 on a number line. Same thing with why absolute value of 4 is 4. 4 is 1, 2, 3, 4 units away from 0 on a number line. So if we think about the absolute value of a number being the distance that number is from 0, that explains why it's always positive, because we don't really measure distances with negative numbers. That doesn't really make sense. We don't say something is -2 miles away. That doesn't make any sense. We always measure distances with positive numbers. So let's try some kind of simple equations here. Absolute value of x equals 4. All right, what is x? What number could x possibly be? I can actually think of two answers for this. Can you think of both of the possible numbers that x could possibly be? Well, there's two possibilities. X could be 4, because absolute value of 4 is 4. We have that up here, in fact. X could also be -4, because the absolute value of -4 is positive 4. So we have to consider both possibilities. And this is going to come up a lot in our equations. In equations where the variable is an absolute value, we're going to end up with two different answers for most of these. All right, number 2 is a little bit more straightforward. Absolute value of -3 is 3. Number 3, absolute value of 2x equals 6. What is x? This also has two different possible answers for x. There are two values that I could plug in for x where our result would be 6. I have to consider two possibilities. Number 1, 2 times x is positive 6. In that case, x could be 3, because absolute value of 2 times 3, 2 times 3 is 6, absolute value of 6 is 6. But x could also be -3, because 2 times -3 is -6, and the absolute value of -6 is also 6. So we have two different answers there. So x is either 3 or -3. Two possible solutions to that equation. Same thing with number 4. There are two numbers that I can think of where x minus 3 is going to have an absolute value of 10. In other words, x minus 3 could be 10, or x minus 3 could be -10. Both of those numbers have an absolute value of positive 10. So we have to consider both. Well, what would x have to be for x minus 3 to be 10? It would be 13. 13 minus 3 would be absolute value of 10, which is 10. That works. Also, if I was thinking of this coming out to negative 10, so the absolute value of negative 10 is 10, well, what would I have to subtract 3 from to get negative 10? It would be negative 7. Negative 7 minus 3 is negative 10, but if I take the absolute value of negative 10, that is also positive 10. So I have two different answers. So x could be 13 or negative 7. But how do we do that? How are we going to find these two different answers? It was not obvious by looking at this equation that we would get 13 and negative 7 as our two answers. So we have to be a little bit strategic here. Right now we're just kind of thinking of the numbers that it could be. But for more complicated equations, we're going to want a strategy. So here's our strategy. Let's look at this example. Solve the equation 2 times the absolute value of x minus 3 plus 1 equals 5 using algebra. Well, the first thing we're always going to want to do is to isolate absolute value. We're going to isolate whatever is in the absolute value. So I start off with my equation, 2 times absolute value of x minus 3 plus 1 equals 5. I'm going to first start by subtracting 1 from each side. So minus 1 cancels the plus 1. On the left, I end up with 2 times absolute value of x minus 3. On the right side, 5 minus 1 is 4. All right, so far so good. Next thing that I want to do, I have this equation. I'm going to divide both sides by 2. I want to get rid of the 2 that's in front of the absolute value. Remember, I'm trying to get the absolute value completely by itself. So that cancels that 2. And 4 divided by 2 is easy enough to simplify. 4 divided by 2 is 2. All right, so I've simplified this equation down so that I have the entire absolute value part by itself. But now what? Okay, so I have to interpret this equation. Absolute value of x minus 3 is 2. The question is, what numbers have an absolute value equal to 2? Well, two numbers have an absolute value of positive 2. 2 and negative 2. Both of those numbers have an absolute value of 2. So I have to consider that x minus 3 could be equivalent to 2. X minus 3 could also be equivalent to negative 2. Both are possible. Both would lead me to a solution. So that's what I'm going to do on the next page. If we flip over to page 100, we're going to continue this problem. So right now, I have to consider two possibilities. I have to consider that x minus 3 is equal to positive 2, or x minus 3 could be equal to negative 2. Both are possible. Both would make the equation work out. The original equation, that is. So I'm going to solve both of these separately. So x minus 3 equals 2. I can solve that by adding 3 to both sides. Plus 3 minus 3 plus 3 cancels. And I get x equals 5. But this is not my only solution. I'm going to get another solution by solving this equation. X minus 3 equals negative 2. I'll solve that by adding 3 to both sides as well. And I get a different answer here. Negative 2 plus 3 is 1. All right, so I have two different answers. That's weird. But let's go back to our original equation. The left side of the equation is 2 times absolute value, x minus 3 plus 1. We're going to evaluate this expression for each solution of the equation. How does this help you check the solutions? So let's find out. I'm going to take each solution and I'm going to plug them in one at a time into this expression and see what I get. So let's start with 5. 2 times absolute value of 5 minus 3 plus 1. If I'm simplifying this, I want to follow PEMDAS. More specifically, I want to follow GEMDAS because I don't actually have parentheses here, but absolute value does act as a grouping symbol. So I'm going to deal with the grouping symbol first. 5 minus 3 is 2. Absolute value of 2 is positive 2. 2 times 2 is 4, and 4 plus 1 is 5. All right. Now let's see what happens if I plug in 1 for x. So I have 2 times the absolute value of 1 minus 3 plus 1. Again, following GEMDAS, I'm going to do this grouping symbol first. Notice I'm not distributing 2. I can only distribute across parentheses. These are not parentheses. So there's no distributing across absolute value. It doesn't really work. So I'm just going to do what's inside the absolute value first. 1 minus 3 is negative 2. Absolute value of negative 2 is positive 2. This is starting to look familiar. 2 times positive 2 is 4. 4 plus 1 is 5. I'm getting the same answer here. And furthermore, it's not just any answer. If I look back to the original problem, this left-hand side was supposed to be equal to 5. So I now have 2 different numbers for x that work in this equation so that the left side equals 5. So the question is, how does this help you check the solutions? Well, we checked the solution by plugging in our solution, our answers, and we got that the left side does actually equal the right-hand side. So it looks like 1 is a solution as well as 5. They are both possible solutions to the equation. So those are our 2 solutions. All right, let's try some more of these because this is a new thing. It's going to take a little bit of practice to get used to. We're going to solve each absolute value equation using algebra. We're going to show each step of work. I'm actually going to start with number 4. Number 4 is the easiest one because it already has the absolute value by itself. I don't have to isolate that. I only have to split this into 2 different equations. So I have to consider that x minus 1, this part inside the absolute value, that could be 2 different things. X minus 1 could be equal to 2. X minus 1 could be equal to negative 2. Both of those have an absolute value of 2. So I'm going to solve each of those to figure out my answer. All right, so I'll solve this equation by adding 1 to both sides. I end up with x equals 3. There's one possible solution. The other equation, I will also add 1 to both sides to get x by itself, and I get x equals negative 2 plus 1 is negative 1. Interesting. So I get 2 different solutions. Both of them are perfectly fine in the original equation. All right, let's go back to problem number 1 since I went out of order here. 4 times absolute value x plus 3 minus 7 equals 5. Remember, we want to get the absolute value part by itself first. I didn't have to do that in number 4. On this one I will have to. So I'm going to work the opposite of PEMDAS or GEMDAS. I'm going to deal with the addition and subtraction first. So I'm going to add 7 to both sides. I get 4 times absolute value of x plus 3 equals 12. The absolute value is not fully by itself yet, so I'm going to get rid of this 4 that's multiplied in front by dividing both sides by 4. 4 and 4 cancel. I get absolute value of x plus 3 equals 12 divided by 4 simplifies to 3. All right, so this is what's going to have to split into 2 different equations. Either x plus 3 equals 3, or x plus 3 could be equal to negative 3. So I'm going to split that into two different equations. Sorry that there's not much room here. So either x plus 3 equals 3 or x plus 3 equals negative 3. I'm going to solve both of those for x. All right, so to solve for x, I want to subtract 3 from both sides. I get x equals 0. That's one solution. Sorry, this is so small. It's kind of scrunched. On the other equation, I'm going to subtract 3 from both sides to get x by itself. I get x equals negative 3 minus 3 is negative 6. So those are my two solutions. Number 2, absolute value of x plus 4 minus 3 equals 1. I want to get this absolute value by itself. So I'm going to add 3 to both sides. I get absolute value of x plus 4 equals 4. And now that I have the absolute value by itself, this inner part of the absolute value could be two different things. There's two possibilities. Either x plus 4 equals positive 4, or x plus 4 equals negative 4. Either one will work. I'm going to subtract 4 from both sides to get x by itself, and get x equals 0 as my answer. I'll do that to the other equation as well. Subtract 4 to get x by itself. Subtracting 4 from the other side, I get x equals negative 8. There's the other solution. Number 3, I want to get absolute value by itself first. So I'm going to subtract 5 from both sides first. I get negative 3 absolute value of x minus 1 equals 8 minus 5, which is 3. I still need to get the absolute value by itself, so I'm going to divide both sides by this coefficient, negative 3. Negative 3 cancels. I get absolute value of x minus 1 equals negative 1. I'm going to pause here. Look at this. Absolute value of x minus 1 equals negative 1. Remember, absolute value always gives us a positive number. This is saying the absolute value of this expression is negative 1. That's not possible. There's no such thing as a negative absolute value. So this happens sometimes. Not all equations are actually solvable. This does not have a solution. So I'm going to write no solution. You can do that if you get the absolute value equals some negative number, because that's not possible. All right, let's finish up these next two problems. Absolute value of x plus 2 minus 3 equals 9. I want to get absolute value by itself first, so I'll add 3 to both sides to cancel the minus 3. Get absolute value of x plus 2 equals 9 plus 3, which is 12. Now that the absolute value is by itself, x plus 2 could be two different things. X plus 2 could be 12, because it's equal to 12, or x plus 2 equals negative 12, because that would also have an absolute value of 12. These two equations will give me two different solutions. I'll subtract 2 from both sides to cancel the plus 2, and I get one solution of x equals 10. On the other equation, I'm going to subtract 2 from both sides to cancel the plus 2, and I get x equals negative 14. Number 6, absolute value of x minus 3 plus 2 equals 2. I want to get absolute value by itself first, so I will subtract 2 from both sides. Plus 2 minus 2 cancels. I get absolute value of x minus 3 equals 2 minus 2, which is 0. Now this problem is a little bit different because when I split up into two equations, x minus 3, well, if I was to split this into two equations, I would get x minus 3, oops, sorry, my computer went to sleep. X minus 3 equals 0, or x minus 3 equals negative 0? Well, 0 isn't really positive or negative, so really these are both the same equation, so I don't need to solve the same equation twice. I'll just do x minus 3 equals 0. I'm going to add 3 to both sides. Minus 3 plus 3 cancels, and I get x equals 3 as my answer. This is the rare case where we get one answer to an absolute value equation instead of two different answers. All right, let's do this last example, which is a word problem. It says the number of shoppers in a store is modeled by y equals negative 0.5 times absolute value of t minus 288 plus 144, where t is the time in minutes since the store opened at 10 a.m. Okay. Part A, for what values of t are there 100 shoppers in the store? Well, I know that t is the time in minutes. Y represents the number of shoppers. The number of shoppers in that store. So if I have 100 shoppers, which variable should I plug that into? Definitely not time. I'm going to plug that in for y. So I'm going to plug in 100 for y equals negative 0.5 times absolute value of t minus 288 and then plus 144. I want to get the absolute value part by itself. So I will start by subtracting 144 from each side to get rid of the plus 144. 100 minus 44 is negative 44. I still have negative 0.05 times t minus 288. I then want to get rid of the negative 0.05. So I'm going to divide both sides by negative 0.05. Those cancel. If you want, I can show you this on a calculator. First of all, I know 44 divided, or negative divided by negative will be positive, so I'm not really worried about that part. What I want to know is 44 divided by 0.5 equals 88. So I get 88 equals absolute value of t minus 288. By the way, dividing by 0.05, remember 0.05 is the same as 1/2. So if you're better at fractions than decimals, you might want to change that to 1/2 and then just multiply both sides by negative 2. Notice negative 44 times negative 2 would be positive 88. It's the same thing. All right, so now I have the absolute value by itself. This is where I want to split this into two possibilities. T minus 288 is either equal to positive 88 or negative 88 in order for this absolute value to equal 88. So, two different equations. T minus 288 equals positive 88, or t minus 288 equals negative 88. I'm going to solve each of these. I'm going to add 288 to both sides. I get T equals 288 plus 88 equals 376. There's one answer. I'm also going to add 288 to both sides of this equation. I don't need a calculator for this. 288 minus 88 is 200. So for what values of T are there 100 shoppers in the store? That's T equals 376 and T equals 200. Part B, at what times are there 100 shoppers in this store? Okay, so that would be, remember T is the number of minutes. So 376 minutes after 10 a.m. and 200 minutes after 10 a.m. So I want to think about 376 minutes. How many hours is that? Well, I know 360 minutes would be 6 hours. So that's 6 hours. And how many minutes left over? From 360, that would be 16 minutes. So 6 hours and 16 minutes after 10 a.m. 6 hours after 10 a.m. would be, let's see, 11, 12, 1, 2, 3, 4. So that would be 4 in the afternoon. So that is the same as 4 in the afternoon plus 16 minutes, so 4:16 p.m. That's one time when there's 100 customers in the store. Now let's look at our other solution. 200 minutes is how many hours? Well, I know 180 minutes is 3 hours. So 180 minutes is 3 hours. That's 20 minutes extra to get to 200. So 3 hours and 20 minutes after 10 a.m. So that's 11 a.m., 12, 1 in the afternoon. So this is 1 o'clock plus 20 minutes p.m.